Okay, now here I have first of all the generator connected in a series connection with the two bulbs. Current comes out of this generator lead through the yellow lead into this bulb back into the generator. I have the meter here in the off position, but I'm going to move it to the 15 volt position. And then these leads don't have clamps, so I'm going to have to put an alligator clamp on the red lead. And I don't remember which one is positive and which one's negative, so I'm just going to take a chance and put the red lead there. Then I'm going to put this lead over here, so that the current has a choice of going through the red lead and into the meter here, then through the meter through the black lead over here and into this side and meeting the generator lead over here. Okay, so I'm clipping directly from generator lead to generator lead. The meter is connected from generator lead to generator lead. And now I'm going to crank. When I crank, the meter went the wrong way. You can't see that. I simply can't get this meter to operate when it's in the upright position, so I can't really show you what's going on here. Actually, let's see here. Maybe I could prop it up halfway and still get it to work a little bit. I don't know if you can see that. Yeah, that works. Should have thought of that earlier. Okay, so don't know if you can see the needle or not. It goes one way if I crank forward, another way if I crank backwards. I crank it in the appropriate direction so that I get a positive voltage. Now you're going to synchronize the cranking with the beeps program, which is very easy to use and very self-explanatory. It gives a beep at any frequency you choose and also a flash on the computer screen. It's actually easier for a lot of people to synchronize with a flash than with a beep. But we crank at a given rate and we measure the voltage. Now we're measuring the voltage from this side of this bulb to this side of this bulb. If I want to measure the voltage just across this bulb, I can take this lead, which goes to the black wire into the meter, and clip it on this side of this bulb. And I can measure that voltage. I could similarly clip it so that it goes across the second bulb. Now there's some shortcuts to how we can clip these things, but I'm trying to do things in the most obvious manner right now. Just to make everything really comprehensible. In other words, well, no, I'm not going to get into that right now. We'll talk about that in lectures. But I can measure the voltage across this bulb at a given cranking rate. And that's how we measure voltage in parallel, where the circuit has a choice between going through the circuit that we're measuring or through the meter. Now, if I want to measure amps, one thing I don't want to do, and I don't know if you're going to be able to see this, one thing I always want to do when I'm measuring amps, even volts, is start cranking very slowly. We don't go too fast. Now you see it doesn't take much of a cranking rate to get the amps up on this thing. That's because this thing is in parallel. And we really don't want it in parallel with amps, because that tends to draw a lot of current through the meter for reasons that we'll see later. And that can blow the meter up, or at least blow the fuse in the meter, and then you're going to have to go out and find the right fuse, and that's going to be a bit of a pain. So you start cranking slowly so that you don't take a chance of blowing the meter up. Make sure the meter's going the right direction, and build up gradually, or you can do some damage. In any case, the way we're going to hook the meter up here, and let me just completely remove the meter from the circuit. Okay, so now we have the circuit. I got these things wet and they're slippery. And you don't normally want to fool around in water with electricity either, as I'm sure you know. We did that because this is low voltage and harmless, but with high voltage, anything you're not sure of, stay away from water. This one is safe in water, but I still don't recommend that you get it in water. Don't get this in water for sure. Okay. Again, we have the series circuit, current through the generator, through the first bulb, through the connecting wire, and I need more colors here because I got confused, but now it's through the connecting wire and back to the generator. To measure amps, we turn this thing to the amps, and we take the clip that's on the red lead from the meter and the clip from the black lead, and what we're actually going to do is we're going to interrupt the circuit. Okay, so we're going to take the circuit apart here, and let's just hook this into the red lead. Now, right now the circuit's not complete. There's nothing attached here. What we're going to do is we're going to attach the black lead so that the current comes out of the generator, has to go through the meter before it goes through the rest of the circuit. And now we can crank, and let's put this up so that you might be able to see something. Now if I crank in the right direction, I can actually measure the current that's going through the circuit, because the current goes through the ammeter in series with the rest of the circuit, not in parallel. And I'm getting a good indication now of how much current is going through the circuit. So that's how we measure current.